Well, before we get started, I want to just chronicle a little bit of things that have been happening in the world that you chronicle so well. And this is all just in the last 2 years. We've had a helicopter fly on Mars. We've had an all-civilian crew in a SpaceX capsule orbit the Earth for 3 days.
You said these are happening in the world, but they're happening in the universe.
Well, that's true. Thank you. I already stand corrected. That's going to happen a lot. We've had the James Webb Telescope send amazing images, which we're going to talk about in a minute. We're going to go back to the moon, then we're going to go on to Mars. Wally Funk has finally been in space. She was 82. Yay. Captain Kirk has really been in space. He was 90, good for him. And we just intentionally hit an asteroid with a spacecraft. Woo, that was amazing too. So is this one of the most exciting times you've seen in space exploration?
Well, I want to offer a possibly deeper perspective on that.
Okay.
And that is when investments go where they should and political and public support lands as people want, then you live in a time where those kinds of developments are exponential. And what's interesting about an exponential growth curve is that wherever you are on that curve, it feels like you're living in a special time, no matter where. So if you go back to 1969, you say, oh my gosh, we landed on the moon, we got this, we got supersonic transport. What are these special times? And we didn't know yet that we would one day be flying a helicopter on Mars and deflecting an asteroid. So yes, these are special times, only because if you do it right, it's all special times.
Well, let me just pick up on that because you're a big cheerleader for NASA. And
yeah, I mean, okay, yes. Yeah, I'm just trying to think. It's not so much that I'm an advocate for NASA.
Okay.
Which I think that's true, but NASA is our agency. I don't want to tell you what to support. What I'd rather do is motivate you to want to support what they do, rather than tell you to support it. I just want to say, look, what it's Mars, and it's
so cool.
life, and you say, wow, and then you go and support NASA. But I don't hit you on the head to tell you how you should spend your tax money.
But you get us all excited about it, and we want to support it.
Totally will do that, if I can.
Okay.
Yes.
Well, I want to, when we're talking about systems beyond Earth, I want to talk about UFOs for a minute. This was a fringe topic. Now it's mainstream, and we have NASA, speaking of NASA, right, looking for intelligent life forms out there. So what do you think? We're going to find them? How are we going to know?
Well, so I don't think it's, I mean, how fringe was it? There was Project Blue Book in the 1960s.
True.
It was all about gathering data on objects that people didn't recognize. And that was an official government investigation. So the idea, it was fringe, and no, it's not, that made a good headline, but I don't know if it was entirely that over all these years. Now, so my feeling is if we were being visited by aliens, you wouldn't need congressional hearings to establish this fact. I'm just thinking, just put it out there. I'm just thinking we would all know. And consider that there are 6 billion smartphones in the world, each capable of high-resolution photos and video. And at any given moment, you guys might have the exact number, is it 1 million people who are airborne, who have windows that look out at any given moment on Earth?
So we would
I'm
have seen
thinking
them.
if mothership showed up, we'd have really good photos of it, and video, and not fuzzy monochromatic
Fuzzes.
tic-tac on a Navy screen in restricted airspace. I'm just thinking. So, and I'm a little disappointed that the government rebranded UFOs as UAPs.
Yes.
They're talking about UFOs, just be honest there. Unidentified aerial phenomenon. By the way, we should investigate anything we don't know is flying through the air. I don't have any problems with some fraction of the Pentagon budget going there, because I want my airspace protected.
Okay.
No problem. And if you don't know what it is, keep investigating. But just because you don't know what it is, doesn't mean it's visiting aliens from another planet. You can't equate your ignorance with knowledge. This is not how you do that. Okay, so now, off planet, yes, we have an active effort, not only to search for alien intelligence with signals, radio signals, but also alien life of any kind. Not only in the subsoils of Mars, but in the atmospheres of newly discovered exoplanets. As they pass in front of their host star, starlight moves through their atmospheres, and you can see the imprint of the chemistry of that atmosphere on the starlight, and deduce whether there's biomarkers in the air. In the old Star Trek series, you ever notice, maybe you didn't, I don't know, when Star Trek folks land on planets, they never have spacesuits. Have you noticed this? They just land and they can breathe. Okay, so what they do is they check first Captain's oxygen, nitrogen atmosphere. Okay, that's like our atmosphere. And you're thinking, among all the planets, that would be, some would have that. No, you only get that. You only get the oxygen if there's life. Oxygen is highly reactive element, highly. So it doesn't last in the air. Something has to keep generating it. So if you find a planet that has oxygen in it, oh my gosh, there's going to be life there. It's not going to be some deserted place with no plants like the Star Trek found, okay? It's going to have plant life or some other thing that's generating oxygen actively. So it is a cottage industry, the search for biomarkers in the atmospheres of exoplanets.
Well, and we're going to talk to those Star Trek people and make sure they get it right next time, right? You know, about a month from now, next month, I should say, NASA's going to try to launch Artemis again, not far from here, and we're going to go back to the moon. What do you think? Should we be going back to the moon? We have our moon rocks already. I mean, do we need to go back? Why is it a good idea to go back to the moon?
Well, we've been to 6 spots on the moon.
Okay.
Imagine landing in 6 spots on Earth, and then going back and say, okay, we know Earth entirely. No, that would be, what are you saying? What are you thinking? What are you doing? So that's a shout out to the geologists who see the entire moon surface as an interesting place, especially in the polar craters, where the crater rim is high enough and the sun remains low enough so that the base of those craters never receives sunlight ever. It is literally a part of the moon where the sun don't shine. And for, sorry. Get to say that, literally where the sun don't shine. And so comets that have hit the moon, comets have made it mostly water and some other ices, but the water that settles anywhere on the lunar surface will evaporate away. But if it settles in the base of a crater where the sun don't shine, it lands there and it stays there forever. So part of the exploration of the moon is there water deposits from billions of years of comet impacts on these at the base of these craters. If you're going to pitch tent on the moon, you might want to be near one of these craters. You don't have to haul water to the moon yourself.
Fascinating.
So the moon is interesting. Mars and beyond, I'm all in. So what do I think of it?
Why not?
I think of the universe. I think of the solar system. If we do it right, we should turn it into our backyard. If you just move into a house and you have a backyard, you say, I want to go to this spot, but not in, I'm going to prioritize. No, you're going to explore the whole backyard. If you're a kid, the whole backyard gets explored. And for us, I kind of feel like we're kids. Look at that, there's a rock and a moon and a this and a that. And so if we equip space access with, here's my dream. Have a warehouse, right? And different size boosters and rockets, and say, what do you need today? There's a front desk. Well, I want to look for life on Mars. Okay, on aisle 3, there's 3 boosters and 2 this, and you get a lab over here, put them together, and you launch. I want to create Disney World on Mars, okay? Or start it at least. you take this combination of rockets. So you build in the capacity to explore and not predetermine what your destination is. People say, where should we go next? Everywhere.
Okay.
Everywhere. And that's how it's always been. In an airplane, you want to go everywhere, especially where no one has been before.
It's true.
Don't tell me, here's an airplane, just go to LA. No, there are other places I want to see. And that's how I feel about the universe.
Well, let's talk about the James Webb Telescope, because it has gone where no one has gone before, right? Far, far away.
Oh, yeah.
Oh, yes. So we're going to show a couple pictures, and I want you to tell us, you can see them right on the screen there.
I got a little screen here, but this is rocket behind me.
Yes, it is. Woo! So we have Carina Nebula.
Yeah,
right?
this is the Carina Nebula.
Right.
So stars are made of gas, and so you say, well, how do you make a star? You make it from a gas cloud, of which there remain many in our galaxy and in other galaxies. And this is a gas cloud that is itself a stellar nursery. And the value of the Webb Telescope is that it's tuned to see infrared light. And the good thing about infrared is that it penetrates gas clouds, and you see farther in than any other band of light will take you. And so you can see the birth of stars, the stellar nursery that this is. And by the way, it's actually interesting physics. The wavelength of red light is longer than the wavelength of blue light. And if you have a fog, you all would know this if you fly, you don't want to shine your blue lights or even your white lights into the fog, because the wavelength will hit the fog particles and scatter, and you'll do a marvelous job illuminating the cloud. Whereas fog lights tend to go amber, and ideally they'd be deep red, but we're not as sensitive to red as we are if you put a little more yellow in it. Amber will penetrate through the cloud, and that's why fog lights are that color. So it's just the physics.
See, yeah, we've all been in that situation where we can't see because of the fog. All right, here we have Stephan's quintet.
Oh yeah. So something that happened in my lifetime through graduate school and my early professional career, we didn't know why some galaxies were just really disturbed looking. Were they made that way? Did they do that to themselves? And only when computing came available in the 1970s, but for science, were we able to show that when two galaxies come near each other, their gravitational fields will distort one another and turn you into something that looks really disturbed.
Okay.
So our catalog of irregular galaxies was really a timeline of what happens to galaxies when they come near others. This is a famous quintet of galaxies that are interacting gravitationally, and it's a circus of what's happening with the gas, the star formation, the clouds, and everything.
And they're all kind of coming into each other because
Oh yeah, because nearby galaxies, even though the universe is expanding,
okay,
if galaxies are close enough, their gravity will overcome the expansion of the universe. So we're going to collide with the Andromeda galaxy.
what's going to happen?
I've got it on my.
Do you have it on your calendar?
It's on my calendar.
Is it marked?
Yeah, October 9th, in 4 billion years. We're going to collide with Andromeda, and it'll look like a train wreck. I want to be around for that. That would be so beautiful.
Okay.
Yeah.
I'm not sure I want to go after that. I'll let you do that
Yeah.
one. I think we have another one here.
Sure.
Yes, here we go. Southern Ring Nebula.
So our nebulae, this is just Latin for fuzz. There's a lot of this in the universe because there's a lot of gas in the universe.
Okay.
And what we call the Ring Nebula and other nebulae, such as this, are the remnants of a dead star. So the bright spot in the middle that's spiky, okay, that's the leftovers of a star that got so big that its outer layers could no longer be held by the gravity, and they drifted into space.
That's going to happen to our sun.
Yes, in fact, yes, our sun will look like this. You don't want to be around for that,
Okay.
just so you know, because as the sun expands, its surface will get closer and closer to Earth, which will make us hotter and hotter, and our oceans will come to a rolling boil. They'll evaporate into the air will evaporate into space, and we'll be a charred ember as we descend into the furnace that was once our star.
Do you have that on your calendar? Do you have that on your calendar also? No.
Yeah, no, I got all of this on my.
And one last picture, the deep field.
Oh,
this is very
that's my
cool.
favorite, because
Yeah,
this is
cool.
mine. Okay, so those spiky things you see are just nearby stars sitting on our nose, and they're so bright that it's an optical effect that happens inside the telescope. The star does not actually look like that. So the spiky things are just nearby. Everything else is an entire galaxy, such as the Milky Way, each containing hundreds of billions of stars. So there are more galaxies in this photo than there are stars themselves.
Wow.
And there's a lot happening here. We don't have time to get into it, but you might see some patterns that look like they're distorted into a circular way. That is Einstein's general theory of relativity at work, because there's a cluster of galaxies in the middle of this image, halfway between us and the edge of the universe. And the galaxies at the edge of the universe are sending their light, and their light, as it comes around that cluster, gets distorted by the distortions in the fabric of space-time. By the time they reach us, it creates these arcs.
But this is looking back almost to the Big Bang, right?
The curved galaxies are the ones that are at the edge of the universe.
Wow.
Just a few 100 million years after the Big Bang.
Amazing.
Right.
Let me talk to you
Because
about...
telescopes are time machines, basically.
Yeah, we're looking back.
We see the universe not as it is, but as it once was.
So I want to talk about one more amazing thing NASA has just done, and that is bumping this asteroid.
Oh, yeah.
Right? Yeah. And I think we might have some video of it. If not, we have a photo. But you know, this was the DART test, as they called it. And
Okay, here we go. Right.
Yeah.
So there's a moonlet. So the main asteroid is the big one, but that's not what we're headed towards.
Right, we don't care.
So this is the collision video. All right. This is like the death kamikaze video of the satellite. And we know how much mass it has. We know how fast it's going. So it has a certain momentum. And as it crashes into this asteroid, it actually will slow it down in its orbit around the main object.
Bam.
Okay, now look at the resolution on this from an asteroid 11 million miles away, yet all we have is a fuzzy tic-tac of aliens visiting in our own atmosphere. Just, sorry to keep harping on that.
No, you're
Just
right.
trying to, just so disappointed in what people are putting forth as evidence. So this is an important first test that we should have been doing decades ago. I'm embarrassed that it's 2022, it's the first time we're trying to deflect an asteroid. Because you know, if the dinosaurs had NASA, they would have been doing this and they'd still be here. You know. So I'm glad the test was successful. In fact, it was more successful than we had predicted for it. And so this is the beginning of an attempt to just set up basically a defense system against that which could render us all extinct.
I think it's fascinating. I mean, they haven't found all the big asteroids out there yet, but they're looking for
Well,
them.
the good thing about the
they'll
big
find them.
ones that would be really bad is that they're easier to detect.
Okay, good.
It's one of the rare things where it works in our favor.
Excellent. So I want to go back some generations to when you were a kid. You were 9 and you were at the Hayden Planetarium and you were thunderstruck by what you saw.
Starstruck.
Starstruck,
Yeah.
okay, sorry, starstruck.
There was no thunder in
Oh,
space.
no thunder, okay, yeah.
There was
No
sound in
weather,
space.
no sound in space. And in a way that set you on your orbit, right? It sent you on your trajectory. So I'm wondering, you know, the folks at this conference, they need kids to be interested in STEM and what's happening and the next people who are designing the aircraft and the space machines and all that sort of stuff. So how do you get kids so interested? How do they catch fire like you did?
I have a fast answer that I think is what you're looking for here. So first of all kids are born curious.
Yeah.
All of them. But the problem is we spend the first year of their life teaching them to walk and talk, and the rest of their lives telling them to shut up and sit down. That's the problem. So the curiosity manifests within children. You should not applaud that, actually. You should be saddened by that. So what should happen is we should not worry about giving them curiosity. We should be worrying about squashing it. Like the kid who pulls pots and pans out from the cabinet and is banging on them, you're gonna say, stop the racket. That's an experiment in acoustics. What is a wooden spoons sound like relative to a metal spoon against a pot. But you as a parent, did you have kids to maintain a clean household? No, that is not possible. So most of what a child does that destroys that introduces chaos into the home are manifestations of curiosity. So if you give them a little more free range, you want to raise free range kids, that'll make sure the curiosity stays. Now, you want to get them into STEM? You know, when I was a kid, we didn't need programs to try to get people interested in STEM because we were going to the moon. I didn't need you to have to set up a program. The moon was the program. The fact that we had astronauts in space that came back, we gave them ticker tape parades. We saw aviation go from subsonic to supersonic, and the planes were getting more and more badass looking, okay? That was going on back then. You didn't need special programs to get people interested. So I've always felt that if you dream big as a nation, then those goals, like the James Webb Space Telescope, kids see that and say, I want to do that. You flew a helicopter on Mars? I want to be there. It becomes its own marketing platform. And you didn't have to spend a dime on a single ad to do so. So my sense is you want to invent the future and have the next generation embrace it, then keep this forward motion on this exponential curve.
Great idea. I'm applauding.
Never take that away.
I'm also calling into question.
Just because she made you applaud, you know.
I'm also calling into question all my parenting skills. I'm revisiting everything. I shouldn't have put those pots away. Anyway, you know, during the pandemic, most of us, I think, watched a lot of Netflix, took a walk around the block, ate too much. You decided, I'm going to write a book. What else should I do? So you have a new book out, Starry Messenger. And in that book, you argue that we need a more cosmic and scientific perspective on life and on the big issues that we're facing. To talk about that, what would that mean?
I'll tell you exactly what it means. So by the way, during the pandemic, I did have the choice. So I was a little behind on my Rick and Morty. I said, I can binge TV that I've been missing, or I can birth an entire treatise on what's been gestating, forgive my uterine references here, but it's been gestating my entire life. When I was 9 and I was first becoming middle school by then, I noticed, I walk around and I see full grown-up people saying things, doing things, and I say, what? You really think that's true? What? How could you, don't you know? And I was realizing that not everybody else was scientifically literate, especially not people who may be in charge of stuff. And this worried me deeply. And so—
As a 9-year-old?
No, into middle school. It took me a couple of years. No, 13, age 13. Yeah, 13, 14, it was like, this world is not going to survive itself unless there's some infusion of rational, logical decision-making. I don't care if you feel one way or another, but if you're going to rise to power and have control over legislation and laws, you better put a dose of objective truth in there. Otherwise, it's the unraveling of an informed democracy. This has been in my head my entire life. And this book is an expression of all the ways things that we argue about, especially at Thanksgiving dinner when your crazy aunt and uncle come over. It's all these things we argue about. Typically, there's another way to view them. Not a compromised position in the middle, maybe that can work, but that's not what I'm talking about. I'm talking about another vista where you say, oh my gosh, my entire foundation was not even rational, but I thought it was. I was born into this world of how people think that way, but it's not. And here's a view where what I thought was a strong argument is not an argument at all. And the best way I can do this is to share with you the opening quote from Apollo 14 astronaut Edgar Mitchell. It is the quote that sets the mood. You pass through this quote to get to the book, because the book issues forth from it. He says, you develop an instant global consciousness a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. From out there on the moon, international politics looks so petty. You want to grab a politician by the scruff of the neck and drag him 250,000 miles out and say, look at that, you son of a bitch. That's a vulgar version of the cosmic perspective.
Okay. Are you interested in going up there and taking a look down, by the way?
Yeah, if I have a destination.
Well, what's your
No,
destination?
because as an astrophysicist, to me, space is moon, Mars, and beyond. I hate to say this in front of this audience, but the billionaire boys space race, okay? If you shrink Earth down to the size of a schoolroom globe and ask how high above that did they go, they went the thickness of 2 dimes above Earth's surface. So I'm an astrophysicist. I can't call, even though it's the Kármán line, okay, but take me somewhere. I don't want to just boldly go where hundreds have gone before.
Okay. All right.
Yeah, send me to Mars on a 9-month trip. Give me a good, streaming account and some books.
You'll tweet from
I'll
Mars.
tweet from space. I will totally do that. Yeah.
All right. Well, we're going to order up your ticket. All right. Okay. Well, let me.
Wait, speaking of tweets, I don't know if it's in your notes here.
Yeah.
But I got in a little bit of hot water when I tweeted about Tom Cruise in his movie.
Okay. No, I wasn't going to ask you.
Just like 2 weeks ago, I finally saw Maverick Top Gun. Okay? It's about airplanes, okay? So, if you saw that movie, you may remember in the first 20 minutes, he's a test pilot, and he ejects from a hypersonic airplane at Mach 10.5 and walks back to talk about it. When you're going supersonic, the air is not naturally parting for you. You have to pierce it. The air is not your friend when you are supersonic, and certainly not when you're hypersonic. And so at Mach 10.5, he's going 7,000 miles per hour, basically into a brick wall, okay? So he ejects.
He's Tom Cruise.
He would be a pile of goo. Yeah, that was the Twitter. He said, no, he's Tom Cruise, he's a superhero, so, and it's just a movie, so get over it, okay? Fine.
I want to ask you one last question because we're running out of time. In your book, you said, I don't fear
I've
death.
only allocated 30 minutes for the whole universe?
Yes, I know.
Okay.
It's hard to believe. I don't fear death. I fear a life where I could have accomplished more. What's on your
That's
list?
on the final
What's
chapter.
on your list? Yes.
Life and death.
Yeah.
So on my list.
You have 48 seconds to tell us what
I
you
can
want
do
to
that.
accomplish.
Totally. There's a quote from Horace Mann, who a great educator from 2 centuries ago. He was in one of his final addresses at the university for which he served as president. He said, "I beseech you to treasure this up in your hearts, these my parting words. Be ashamed to die until you have scored some victory for humanity." And so all I've done with my life is attempt to do just that, to just up science literacy a few notches. That is the foundation of all of what we cherish in civilization, and particularly a community that is on the frontier of what technology and science can bring to civilization. Let the world be a better, safer, more secure, healthier place for you having lived in it. And this is, that's my guiding star.
Thank you so much. It's been delightful to speak with you. It's been so much fun. Thank you.